Okay, in this video we're going to talk about zero and negative exponents. A non-zero number to the zero power is 1. Okay, any non-zero number. Okay, so there's A representing any non-zero number to the zero power equals 1. Okay, and notice it says that A is not allowed to equal 0. And here are a couple of examples. 15 to the 0 power equals 1. Negative 7 to the 0 power also equals 1. And notice the parentheses here around the negative 7. If we were to write it this way, negative 7 to the 0, that would mean the opposite of 7 to the 0, and the answer would actually be negative 1. Okay, so make sure you understand that's what that would mean. This would represent the opposite of. And then that would be 7 to the 0. And so the opposite of 7 to 0 would be negative 1. And that's zero exponents. Now negative exponents, a to the negative n, okay, is just the reciprocal of a to the n power. So a to the negative n is just equal to 1 over a to the n power. Okay, that's the reciprocal. Again, a is not allowed to equal 0, and n is a positive integer. Okay, so since n is a positive integer, that makes the exponent, that makes this negative, and then that would be positive. Okay, and that's because it says n is a positive integer. So down here at the bottom you have 5 to the negative 2 power. That's equal to 1 over 25. And there's a couple of different ways you can look at that. Okay, that could be 1 over 5 squared. Of course 5 squared is 25. Okay, I also sometimes think of it as 1/5 squared. And so 1/5 times 1/5, and that equals 1/25. And on this other one then you have 1 over negative 3 to the 3rd power. And so negative 3 times negative 3 times negative 3 is negative 27. When you write the answer, generally you put the negative sign on top, so it's negative 1 over 27. Okay, or sometimes I'll take the reciprocal of negative 3, which is negative 1/3, and change the exponent to a positive 3. And negative 1/3 times negative 1/3 times negative 1/3 would be negative 1/27. On this page I have a few examples to go over. In the first one, x to the negative 8 power. This is just going to be 1 over x to the positive 8. And the other thing that I sometimes, again, think of it as take the reciprocal of x, that would be 1 over x, and then change the exponent to the positive 8. And you can think of it that way. 1 over x to the 8th power. And that would be 1 to the 8th power over x to the 8th power to give you the correct answer. For number 2, first thing you have to make sure you realize is it means 5 times x to the negative 2. So the 5 is not the base for negative 2. So whatever you're going to get 5 times that. Okay? And x to the negative 2 is just 1 over x squared. And so when you multiply, you put the 5 over 1, and you do 5 times 1 is 5, and 1 times x squared is x squared, and your answer is 5 over x squared. And for number 3, it's x to the negative 3rd times y to the positive 7. So the x to the negative 3rd is 1 over x to the 3rd times y to the 7th, which could be y to the 7th over 1. When you multiply your fractions, you get y to the 7th on top, you get x to the 3rd on the bottom, and there's your answer. Now 4 and 5 get a little bit trickier because of the negative exponents being in the denominator. Generally, what I would talk about is if the exponent's negative, and here I have a negative exponent, and what you want to do is you want to take that base and move it to the top. So I want to take my base of x, and that's going to go to the top. And that will change the exponent from a negative to a positive. And then on the bottom, I still would have the 5, and I still would have the y squared, and that's going to be the answer. So the only thing that's moving is the negative exponent. And if you look at the first 3, that theory still kind of holds. In number 1, you had x to the negative 8. Well, that's in the numerator. And so then it moves the x to the denominator and changes the 8 to a positive 8. Same thing with the x to the negative 2 in question 2. Goes to the bottom and becomes x squared. And in number 3, the x to the negative 3 goes to the bottom, becomes x to the third. And then in number 5, I have the negative exponent. Here's the negative exponent, right, but it's on parentheses. So that's the whole base. That whole base is going to go to the top. The whole base, 3x, and I would change that from a negative 2 to a positive 2. The bottom, since there's nothing left, I have to make it a 1. And now I just take 3x squared. 3 squared is 9, and x squared is x squared, and that's the answer. If I take this, and I'm going to put it on the other side, next page here. Now let's look at another way to do this. See if I can maybe explain a little bit more. If I do this the long way, I'm going to take 3 and raise it to the negative 2, and I'm going to take x and raise it to the negative 2. Well, 3 to the negative 2 would become 1/9, and x to the negative 2 would become 1 over x squared. Now I have a numerator as 1. When I multiply across, I'm going to get a denominator at the bottom. 1 times 1 is 1, and 9 times x squared is 9x squared. And I'll take this division problem I just had and take it from being vertically to being horizontally. 1 divided by 1 over 9x squared. So again, all I did was take my vertical division problem with a fraction bar, change it to the old-fashioned division sign, make it horizontal. When I divide with fractions, I'm always going to multiply by the reciprocal. So I would take 1 over 9x squared and make it 9x squared over 1. Okay, the beginning part still stays 1. And all I'm really going to do then is take 1 times 9x squared. And 1 times 9x squared is 9x squared. And that answer is the same answer that we just had right here. Okay, but this way is a lot simpler. You take the base, there's the base, move it to the numerator, 3x, parentheses around it, change the exponent from negative 2 to positive 2, and you just follow the rules there. 3 squared and x squared, you get 9x squared. Again, same thing that you have right there.